All right, motion test corrections part 3. We're now on number 13. Motion of a toy car. We've got a distance versus time graph again. And we've already said in some of the previous questions that if we have something that looks like this, that means that this object is slowing down. Now, it's not curved all the way. Like this part through here looks like a fairly constant velocity. And obviously here, they've gotten to the point where they're not moving at all because it's flat. All right, select all of the statements that are true according to the graph. The toy car was speeding up. No, the toy car, if doing anything, was slowing down. The toy car slowed down between 2 and 4 seconds. Well, I think that's accurate because that's the curved part of the graph right through here. Okay, it was moving at a constant velocity in the red part, slowing down in the yellow, and in the green part, wasn't moving at all. So the toy car slowed down between 2 and 4 seconds. Yes, I would say that that's true. The toy car did not move after 4 seconds. I would say that's true because at 4 seconds, it's at the 3-meter mark, and it's still at the 3-meter mark 2 seconds later, so it's not moving anymore. The toy car was speeding up, then moved at a constant velocity. Speeding up and then moving at a constant velocity would look something like, oops, sorry, y'all can't see what I'm doing. Speeding up and then moving at a constant velocity would be a graph that looked something like that. So, not true. The toy car covered a distance of 2 meters in the first 2 seconds. In the first 2 seconds, it did cover a distance of 2 meters. So, that is also true. So, you should have 3 things checked: that the toy car slowed down between 2 and 4 seconds, that it didn't move after 4 seconds, and that during the first 2 seconds, it did move a total of 2 meters. Okay, number 14, a bus traveled 100 kilometers per hour for 15 minutes. How far did the bus travel? All right. This makes me want to cry. A lot of people are like, hey, 100 times 15. And they say 1,500. And that is wrong. Okay, if you did that, here's what you didn't do. The 15 minutes, that's minutes. But it's asking about a bus traveling, and it's traveling in kilometers per hour. So what I need to do here is I need to recognize that 15 minutes should be converted into 1/4 of an hour, or 0.25 hours, okay? And guys, this should raise a red flag to you. If a bus is traveling 100 kilometers per hour, it cannot possibly go 1,500 kilometers in 15 minutes. That's just nonsense. Okay, so it's obviously not 100 times 15. It's 100 times 0.25. Or you could have said 100 times 1/4. Or you could have done 100 divided by 4. Bottom line is 1/4 of 100, it goes 25 kilometers in 15 minutes. Okay, so you would put 25. You don't need to worry about trying to put units because you can't really enter that on a DMAC test. Okay, number 15, a lovely graph. This time the graph has speed on the y-axis and time on the distance axis. Okay. When is the object moving at constant speed? Okay, guys, we've got to look one part at a time. Here, it started at a speed of 0, and by the end of this interval, it was going a speed of 15. So during that interval, it was speeding up. Because again, this is not a distance versus time graph. This is a speed versus time graph. In the next interval, interval B, it started at a speed of 15. It ended that interval at a speed of 15. So it was moving at a constant speed or moving at a constant velocity. Okay. interval C, started that interval at 15, ended that interval at 25 meters per second. So again, this is another place where they are speeding up. Last one, they started at 25 and ended that interval at a speed of 0. So here in interval D, they are slowing down. Okay, when is the object moving at constant speed? All right, so that's the question. When is the object moving at constant speed? Well, we've identified that it's during area or section B. Because section A, we're speeding up. Section C, we're speeding up. Section D, we're slowing down. The only time we're moving at a constant speed is section B. All right, next question. Same graph, different question. Describe what is happening in part D of the graph. Well, we've already done all the hard work, so we'll just look at this back one, down here. They said, what is happening in part D? And we've identified. We started at a speed of 25 and ended at a speed of 0. So obviously during interval D, we're slowing down. Moving at constant speed? Nope. Objects moving at a constant speed back towards the starting mark? Nope. It's not moving at a constant speed, it's slowing down. Because remember, over here, it's not distance, it's time. The object is speeding up at a rate of 2. Nope. The object is slowing down. All right. Next, we have a question about planet boson. On planet boson, scientists measured a falling object that went from 0 meters per second to 15 meters per second in 3 seconds. What is the acceleration of the falling object on boson? Okay, so we know that acceleration is a change in velocity divided by a change in time. Or we could say it's the final velocity minus the initial velocity divided by time. Our final velocity was 15. Our initial velocity was 0. And it took 3 seconds to do that. So a change of 15 meters per second, which took 3 seconds to do, is an acceleration of 5 meters per second squared. Now, again, on the test, you couldn't really put in units, so just worry about the number. Okay, 5 meters per second squared. All right, and then finally, question 18, an object that is moving must be accelerating. That is false, and here's why. An object can be moving at a constant velocity. In other words, or said a different way, an object can be moving even if it's not speeding up, slowing down, or changing its direction. Smiley face. All right, so yes, an object can be moving even if it's not accelerating. Okay? Because it could be moving at a constant velocity. It could be moving, in other words, without changing the way it's moving. Okay? Changing the way it's moving is acceleration, and that comes in the form of speeding up, slowing down, or changing direction. So finish this up, make sure that you've made all of the changes in the notations, and then you can submit this for your test corrections.